Assalamu alaikum and a very warm welcome to everyone. Welcome back. Now, today we're going to discuss on the design pad on slope stability. In this design pad, a total of 8 problems were given, and we're going to be discussing on this in detail. Now let's start off with the first problem. The specification given as follows. Now this figure here shows a 4.5 meter cut through 2 soil strata. So from here you can know that there are 2 soil strata, one over here and one over here. The lower is a highly cohesive soil. Okay, shouldn't be a problem here. Shearing strength data between 2 strata are as follows. So the cohesion is given as 7.5 kilonewton per meter square. Angle of friction is 25 degrees. And the unit weight of upper layer is 16.5 kilonewton per meter cube. And there's assumption of neglect the effect of soil water between 2 strata. So as mentioned before, if a soil water exists, okay, then this approach is not valid. So you gotta be check on this. And the required is pretty simple, factor of safety against sliding. And the solution as follows. Now from figure E3, you need to identify which one is L, which one is H. And then you use the equation, and L you will be calculating as 6 meter and H as 1.22 meter. So this is very straightforward. Next, from equation E1, so look at your notes, find W. So you get W around 60.39 kilonewton per meter, and then you follow by equation E4, which is to find the factor of safety. So from that equation, the factor of safety is approximately to be 2.37. And then you got to write a statement that 2.37 is more than 1.5, refer to the table, hence it's okay. Now let's move on to the second problem. So this scope is under slope in homogeneous soil possessing cohesion. The previous one was a very simple concept. What are the specs? Let's read up. So a vertical cut is to be made through soil mass. So when you talk about vertical cut, it has to be a 90 degrees angle. The soil to be cut has the following properties. The unit weight as 16.5 kilonewton per meter cube. The cohesion is given as 25 kilonewton per meter square, and the angle of friction is 21 degrees. And what is required? So the safe depth of cut in this soil. So I like to know the safe depth, okay, by using Kalman's method, and the factor of safety is given as 2. Remember, in Kalman's method, there are 2 governing factor of safety. One is due to the cohesion, and another one is due to the internal angle of friction. Okay, so in this case, the factor of safety is 2. So in theory, both Fs should be 2. From there, you're going to work out your problem. So first, find the developed cohesion CD. Okay, so your Fs is 2 due to the cohesion. So you'll be likely to get 12.5 kilonewton per meter square. And then you're going to find the second contributing factor, which is from the internal angle of friction. Use the same Fs, and you're likely to get 0.192. Okay, and then you're going to compute H by using the main equation given in E11, and the safe depth of cut is 3.66 meter. Now let's look at the third problem. Still under slope in homogeneous soil possessing cohesion. Now specification, a 1.8 meter deep vertical wall trench is to be dug in soil without shoring. Unit weight is 19 kN per meter cube, cohesion is 20.2 kN per meter square, and the angle of friction is given as 28 degrees. Okay. So what does it mean? So when you talk about vertical wall trench, it's 90 degrees angle, and without shoring, there's no support for this when you dug. Okay. So what is required factor of safety of this trench using the Kaufman's method? The solution, so this approach is going to be a trial and error approach. So you have to assume the factor of safety because it's not given. So I would like to have my first safety factor as 1 for the internal friction of angle. Okay, I use the given equation and I'll compute for internal angle of friction. Okay, that's my second step. And my third step is to find the developed cohesion. Okay, and then I'll calculate my factor of safety as 3.93. Then I'll make a comparison between two factor of safety. So I know that 3.93 is not equals to 1, that as I have assumed earlier. So I need to have another trial factor of safety. Okay, so this is my first assumption. So the second assumption, I assume my Fs due to the internal friction of angle is 2, and I'll calculate my factor of safety due to cohesion is 3.07. Still is not the same, and then I move on to 3, and I'll get roughly about 2.82. Still is not the same. Okay, and by theory, the factor of safety of both should be the same. All right, so I have another approach. Okay, I'll write a statement because my Fs for cohesion is 2.82 is not equals to the Fs due to the internal friction of angle is 3. The correct factor of safety has not yet been found. Rather than continue this trial and error procedure, I'll take a shortcut. The values of both factor of safety are plotted, from which the applicable factor of safety about 2.84 can be read. So if you look at the next slide, I will plot this 3 points in FSC versus FS phi graph. Okay, so this is the first point would be 3.93, which is this one, my first point, second point, and third point. Then I will draw y equals to x line. So when my y equals to x line intersect with my curve due to these 3 points, I will determine the factor of safety for both. So in this case, my factor of safety is 2.84, which is representing both factor of safety. One is from the cohesion C and one is from the internal friction of angle. So this is much easier approach. Now let's look at problem number 4. So this is slope in homogeneous soil possessing cohesion. So the specification is given in a diagram form. And what is required? Factor of safety against failure using stability number method. Previous was Kalman's, now is the stability number method. So the difference is that you need to find the n value. Now the solution. First, you need to identify, because the given angle of internal friction is greater than 3 degrees, the failure surface will be a toe circle. So this is from the notes. The same procedure, I would like to have a trial and error. So firstly, I assume my factor of safety due to the internal friction of angle is 1. Okay, So the addition thing compared to the previous problem is that I need to calculate for n values. So from figure E10, I can calculate for n values. From there, you repeat the same procedure as previously. So I assume Fs due to the internal friction is 1, and I calculated factor of safety due to the cohesion as 1.46, which is not the same. In theory, this should be the same. So I keep repeating the same procedure. I assume 1, I get 1.46. I assume 1.2, 1.37. I assume 1.5, I get 1.26. Still is not the same. So next, what do? I make a shortcut. So I plot the values in this graph, FSC versus FS5. I have 1, 2, 3 points, and then the point that intersect with y equals to x line is the factor of safety that represent both parameters. One is from the cohesion and one is for the internal friction of angle. So the factor of safety from this graph is 1.36. Now let's look at the problem number 5. So this scope is still on slope in homogeneous soil possessing cohesion. Now specification given as follows. But right now you are given the internal friction angle is 0 degrees. So this is different from this problem. Okay, in this problem, the internal friction is given as 10 degrees. So there's a value. But for the next problem, your internal friction angle is 0 degrees. Okay, so the approach differs because it needs to refer to different diagram. So let's look at the specification first. A cut 7.5 deep is to be made in a stratum of highly cohesive soil. The slope angle beta is 30 degrees. Soil exploration indicate that bedrock is located 12 meter below the original ground surface. And the soil has a unit weight of 18.84 kilonewton per meter cube, and its cohesion and angle friction are given as 30 kilonewton per meter square and 0 degrees respectively. So what is required? Factor of safety against slope failure. Now the solution is given as follows. By using figure E8A, okay, you can calculate for your ND, which is 1.60. And with a slope angle of beta 30 degrees and ND is 1.6, you approximately get your NS as 6 from figure E9. And figure E9 is only valid when you have internal friction is 0 degrees. Okay. Now by using equation E12, you can calculate for your required cohesion. So it's calculated as 23.55 kilonewton per meter square. And lastly, you can calculate for your factor of safety. So here, your factor of safety is 1.27 based on factor of safety due to the cohesion. So the internal friction of angle is not given, means is 0. It's given, but it's 0 degrees. So what's left is just factor of safety due to the cohesion. That's why you end up using just this equation. Pretty short and simple. Now let's look at problem number 6. Specification as follows. So in this problem, you just need to find what is beta. The same step, you just need to find what is beta. And then your internal friction is given as 0 degrees. So you should know which chart to use. So if you follow this procedure, you'll be able to get your beta as 23 degrees. And let's look at the next problem, E7. A cut 10 meter deep is to be made in soil. The soil has a unit of 17.66 kilonewton per meter cube, and its cohesion and angle of friction are given as 19.2 kN per meter square and 16 degrees respectively. The factor of safety must be 1.25. So the factor of safety is given 1.25. And what is required? You need to find your slope angle. What's different between this and the previous is that in this problem 7, internal friction has a value. You just need to refer to the respective graph in order to get your n value. And in the end, your slope angle will be likely to be 44 degrees. Now, this is the last and important problem that you will encounter during your work, which is the method of slices. Let's look at the specification. The stability of a slope is analyzed by the method of slice, because you see slices here. On a particular trial curve surface through the solid mass, figure above, the shearing component, which is the sliding force, and the normal component, normal to the base of each slice weight, are tabulated as follows. So as a geotechnical engineer, you will need to calculate this. But for this example, this one is given for you. Okay, by right, one by one, you should calculate using the formulation given. Now, the length of the trial curve surface is 10.8 meter. So this is 10.8 meter. The angle of friction of the soil is 5 degrees, and the equation is given as 19.15 kN per meter square. So what is the required? Factor of safety of the slope along this particular trial surface. Pretty easy. So if you use the equation in your notes, which is E13, this is the main equation, your C you just replace with the 19.15 kN per meter square, and L is 10.8 meter. So you solve for this part, and the rest needs to be taken from this tabulated form. Okay, so if you follow this accordingly, you'll end up calculating your factor of safety using this method of slice as 2.06. And you got to have a statement. It should be emphasized that the computed factor of safety of 2.06 is for the given trial surface, which is not necessarily be the weakest surface. So that's all about it for slope stability analysis. I hope you do this, and any question just pop up anywhere you like. Thank you very much.